Thank you for joining IntelliMagic for the webinar today, Avoid Service Disruptions from Storage Using Built-in Knowledge. My name is Jessica Thompson, and I'll be the moderator for today. Your speakers from IntelliMagic are Brent Phillips, who is responsible for the IntelliMagic business in the Americas region. He has been working in enterprise computing environments for over 30 years and directly with large IntelliMagic enterprise storage customers for over a decade. And Brett Allison is the Director of Technical Services at IntelliMagic. He is a deep specialist in performance and availability solutions for enterprise storage environment. Just a few administrative items before we get started. Please feel free to ask questions throughout the webinar, and we will be answering them as we go along. You will see the questions panel located on the right-hand side. Also, we'll be giving away a $25 Starbucks card. So you'll be entered into that drawing each time you ask a question, and at the end of the webinar, we will randomly pick one winner. This webinar is being recorded, and we will post a link to the recording after the webinar. With that, I'll hand the webinar over to Brent Phillips. Brent?
Okay, thank you, Jessica. I appreciate your time, everyone, for joining us this afternoon or morning, based on where you're at. So we will have a discussion about these four topics. Availability intelligence is really the methodology that, or what we call the methodology of applying this built-in knowledge to the performance data. So I'll talk about that for a little bit. In particular, it's for the context, or in the context of these particular hardware environments. If you don't have block storage from EMC, IBM, HP, or HDS, and Fabric from Cisco or Brocade, then you might not be that interested in this. But on the other hand, if you do have service disruptions on this kind of hardware, it should be quite an interesting session for you, I think. Brett Allison will do parts 2 and 3, talking first of all a little bit about modeling storage performance. As far as I know, we're the only vendor in the world, actually, of storage performance modeling software. We've been doing that for over 20 years, and this is really the source of some of the expert domain knowledge that we apply to the performance data. So we think it's important just to spend a few slides talking about what we do there and how we do that, and then how the monitoring solution grew out of that. And that's part number 3, where Brett will cover a couple of use cases using this. Some screens produced by the solution to kind of give you an idea of the types of things that are possible using this approach to solving the problem of avoiding service disruptions on the storage environment. And then I'll wrap up with just a couple of slides about how this is available as a service or as software that you can install on site as well, and then some possible next steps that you might be interested in. As Jessica said, we do like questions. So please use the question panel there to submit any questions, and we will try to pay attention to that and address those as we go along. So one slide just about who we are and our background. We are a company that is inspired really by this idea of creating some new ways to uncover these risks that are hiding inside the IT infrastructure. And we tend to attract employees and customers who are interested in pushing the barrier on what's possible regarding this approach, and for the kind of reasons as we talk about in the title of this presentation, to see and resolve issues before they impact your production users, for example. You've seen on the title slide, as well as on this particular slide, a picture of an old lighthouse. This one is actually out of Denmark, taken by our founder. And we're kind of inspired by lighthouses as well, because we see a correlation between what they were built to achieve and what we're trying to do with IntelliMagic and the technology that we produce. Essentially, in those days when lighthouses were active, they were quite an important part of the process of making sure that you didn't run into any dangerous objects under the surface of the sea that couldn't be seen, or particularly at night and when it's stormy and you can't navigate by the stars. How do you know where you are and how close you are to the danger? It's the power of knowing where you are in relation to those dangerous objects that really made the difference. They were, of course, outdated by GPS technology. After the Korean airliner was shot down, the U.S. government released GPS technology to the commercial sector, and that really put an end to the usefulness for lighthouses because there's a more effective way. And when you think about GPS technology, it's a similar kind of concept. It will tell you where you are exactly, and that's not that useful unless you know where you want to go and where the dangers are that you want to avoid. So the map itself in that example serves as that expert domain knowledge that without the map correlating your position on that map, I mean, it's just not that useful technology. So that's the same kind of thing we're trying to do in the information technology world today. And this is the way we see things today, that either things are good and everybody's happy, or there's an incident and it's kind of a crisis mode and everybody's in firefighter mode trying to resolve the issue because production applications are impacted and users are on the phone and so on and so forth. So it's a pretty difficult environment to solve problems in that way, in that mode. We think there's certainly room and the possibility for a middle layer here where you can actually see some warning levels of risk in the infrastructure to handle the peak workloads while the service levels are still good, and be able to work on the problem, with a healthy level of stress and focus, and with brain psychology. I mean, it's just much more productive to have that kind of environment to see and solve the problems before you get to that bottom stage there. And it's this idea of treating this problem about seeing risk in the environment to handle your peak workloads with acceptable service levels, being able to see that as we see the security problem, for example, as a threat, as opposed to responding only after the incident already impacts the production environment. So what do you need to do that? Well, one of the things that we talk about is the instrumentation that's just not there in the SAN infrastructure. Despite the high price that we pay for this infrastructure, it doesn't have the same kind of capabilities that you have on an average $20,000 automobile. This, of course, this is a dashboard of a Porsche 911, so it's not your average $20,000 automobile. It's just a little more interesting example to look at. But the concept applies to any car out there so that the average driver can understand there's an issue that needs to be dealt with that can threaten the reliability of the engine. For example, the oil. If the oil pressure is too low, I mean, none of us really know what pressure is too low or not in terms of the actual metric. The gauge will interpret, the warning light will go off, or the temperature of the engine, or even things like the RPMs on the, I mean, there is a red line there. How would you know whether 6,500 RPMs are too much for the engine to handle or not? I mean, it's interpreted for us based on some engineers building in their expert knowledge to understand what's good and what's bad. And we don't really have that for a large extent from a performance and availability perspective on the storage infrastructure by default from the storage vendors. Another example of creating some new metrics is also from the automobile world, where you can use infrared technology and interpret that data to allow drivers to see something that's difficult to see with the naked eye, that's quite important to see, so that you can take corrective action. These are the kind of things that we want to do for the technology infrastructure. So today, most of the incidents that you have, the service disruptions from the storage infrastructure, you probably consider those as being unpredictable, because if you could have predicted it, you would have done something to avoid it. That's the easiest thing to deal with. But for these unpredictable ones, I mean, most of the focus from the vendors these days is how do you find out about the problem happening quicker? So you don't have to wait for your phone to ring and unhappy users. You can get alerts in other ways when service times are too high. And how do you understand what the root causes are for the problem so that we can accelerate the fix and get things working back normal again? But what would it be like if you could convert the big red section to be mostly blue, mostly predictable? I mean, what would that mean for how you operate as an IT staff instead of that bottom mode 24/7 trying to figure out problems, being able to see the risk and address it before any of the production users ever feel the pain or transactions. So that would affect employees and customers as well, obviously. This is the way we see the problem today, is that response times will go up, and if you have some thresholds and automated monitoring, they're typically focused on the service times, the response times. So you really only find out about it after it's already up in this red area here. So the reason that they're all triggered on that is because it's an easy metric to get, but it's really an effect of other issues. It's not a cause in itself. So to be able to detect it earlier down here before response times goes up takes a different set of metrics. For example, it takes monitoring the utilization or the saturation levels of the different components in the storage infrastructure. That requires, some expert domain knowledge. I mean, if we're talking about the ports on the front end of a storage array, you have to know, what the make and model is, what speed they're at, how many are there, how many megabytes per second are flowing through those during your peak periods, every hour of every day, basically. So it is a different kind of game, and that's really why most people are not able to do that these days. But that's how you're going to really get out of the mode of being a firefighter and being more of a, having a strategic focus for understanding what the threats are and being able to navigate around those threats before the knee of the curve of response time goes up, because that knee is pretty sharp these days. When any particular component becomes overloaded, it will increase the response times to an unacceptable level pretty quickly. If you can see that and deal with the root cause, you can address the issue and keep response times in an acceptable range. So this is what we call availability intelligence, this process of understanding really what's going on inside of the storage infrastructure, inside of the fabric, so that you can have this foreknowledge about these hidden threats to availability. Because most of these things are really not in the unpredictable stage most people think that they are. If it's an issue on the storage infrastructure, a lot of times it is predictable. Not everything is predictable, and in that case, then the objective is not just to avoid the incident, obviously, but to accelerate the resolution. And that's a step that needs to be done whether you find out about it before the end users notice the problem or your other symptom monitoring solutions or alerts go off, or whether it's after. I mean, you got to fix the problem one way or another. And so there's a lot of benefits about interpreting the performance and the configuration data using a base of expert knowledge like this to get better visibility about what's going on inside of the infrastructure. And that's really the secret on why we're different. And it's important, I think, to point out that it's not enough to have just better visualizations and charts and graphs and this kind of thing. And it's not enough even to have a statistical analysis. We think that this is a good step in the industry. There's a lot of vendors out there in the ITOA area that are using this mathematical analysis of the data, of the machine-generated data from different sources, so that you can recognize anomalies according to your normal base patterns, so that you can do correlations of the data and understand things. And we think that's useful. We do some of that as well. But our point is that without this hardware knowledge built in of what the different components are doing and what they're capable of doing and how close to the edge of those capabilities you are, you're going to miss this whole picture and this idea of foreknowledge and quantification of the risk of that infrastructure to handle the peak workloads. Because you really need to know, is what you're looking at, is it good or bad? It's a line chart, but in the context of your particular flavor of workloads on your particular hardware components that you're running on, is it good or bad? What's the risk of unacceptable delays being introduced into your workload response times if your workloads change and grow by 5% or 10%? That's pretty important to know if you really want to get to this stage of dealing with things ahead of time. And you need to derive some new meaningful metrics out of the raw data often in order to do this kind of thing as well. And we do some of that, as well as applying some of the best practices on how the configuration ought to be be able to manage the infrastructure better and to create an appropriate balance of workloads across the physical resources. And it's important to also visualize, have a way to easily visualize what is the risk and how is the risk changing from hour to hour and day to day, so you can do something about it. So making this a little more, or a little less abstract, I suppose I could say, for the storage infrastructure that you work in today, let's talk about how we can illuminate some of these threats inside of the storage arrays. And it starts with the different kinds of measurements. Again, a leg measure is more of the effect, not the cause. A lead measure is something that would predict what that leg measure is going to be. So an example I like to use that's very simple to understand is if the problem is how to lose weight, you know, you get on the scale, that's the leg measure for losing weight. How many pounds do I weigh? If that's the only thing you're tracking, it's pretty hard to make some effective changes to get the result that you want. The lead measures that will predict what that leg measure is going to be are things more like how many calories am I taking in each day and how many calories am I burning. If that's what you're focused on and making adjustments on, you're going to be more effective. So it's the same principle for a storage array. The leg measure is a response time. What are the lead measures that you can monitor? Well, on the front end of a storage array, some of the most common reasons that delays get entered into the service times are from adapter utilizations, depending on the make and model. But this is something we see fairly often, that the front end of the storage array gets overloaded during peak periods. Too much throughput, megabytes per second, are being asked of those particular ports. So if you know at what point it's going to start to introduce delays, at what point you're going to hit the knee of that curve where response times will go up, you can start to generate some warnings as the peak periods are approaching those and do something about it before the response times go up. On the fiber switches as well, I mean, the data rate is so high that it's pretty sensitive to errors, and you know, it's good to track that and see those changes before it gets too significant. On the back end of the storage array, there's some significant lead measures as well, because it still matters to how fast the actual disk devices are staging the data from those devices into cache for the reads, and you know, destaging from the cache to the devices for the writes. If the hardware can't keep up with that, there will be delays introduced into the system. The fast write bypass, that's nomenclature from one particular vendor, but it's kind of an emergency destage operation that slows down the production workload so that the array can keep up with the destaging that it's being asked to do. So these are things that you can monitor and understand when there's some issues that need to be addressed. There's other types of things as well, like imbalance within an array. Automatic tiering can address some of these, but that also introduces some additional need for visibility to understand how that's operating and you know, how you set it up on which types of devices, or between arrays as well. I mean, often when we see some issues, there can be plenty of physical resources in the environment to handle the workloads, but it's really more of a balance of the work across the physical resources. Or maybe monitoring the changes in the environment as well. Has the application changed from one day to another? That's one of the things that may not be predictable unless this kind of approach is used in the development and test part of the cycle. But it's easy to be able to see if you can break down the workloads and have a way to flag what's changed, or maybe it's a configuration or microcode update that bug in it or something of that nature. So this is kind of our idea on how we apply the expert domain knowledge to get visibility into these types of lead measures. There's 7 different areas that we add expert knowledge into the process of when we collect the machine-generated data. It's in the collection process, of course, of what to collect, how to normalize the data into tables, how to enrich it by calculating additional metrics, how to assess what we're looking at. Is it good or bad? And then actually rate it based on the types of workloads and the characteristics of the specific hardware components that are in use, of how severe is the issue, or how close to the edge of the capabilities. And then we work pretty hard to build in some recommendations as well, so that when you're looking at an exception report of, we think these are unacceptable levels of risks in your environment, where do you go from there? What do you look at from there? So again, the objective is to avoid or resolve incidents before they affect your production workloads, and to accelerate the fix, whether it's something you found early or whether it was something that was really unpredictable. And then a final slide before Brett takes over. It's important to point out, I think, the power of going through this kind of process using automation to be able to look at every device in every data center, every interval for the data. It's something that's just not possible to do even with an army of very smart people, but it's how you get the benefit of understanding how things are changing on a day-to-day basis. So if you look at the ITIL definition of capacity management, I mean, it talks about considering all of the resources, or you could say all the components required to deliver the IT service, and are they situated such that your service level targets will be hit, that they're safe to hit. You really can't do that without this kind of process, automatic applying this kind of expert knowledge to the data all the time and seeing how it changes. Actually, okay, these slides are in a couple of slides about the visualization are in my section before we go to Brett. The top level roll-up of the risk analysis that we do, this is a sample of that. In this case, there's 3 subsystems in the environment. This can be a really long report. We have customers that have really large environments as well. But this just gives you a kind of a snapshot idea of what you would be looking at. We call them key risk indicators. There's a number of different measurements we'll look at and we'll assess and rate. And if everything is in an acceptable risk level, then it'll be small and green. It will turn yellow and then bigger yellow and then small red and bigger red based on the nature of the violation. So it makes it very easy in just a minute or 2 per day to understand, has something changed from yesterday to today in terms of my risk profile of handling my workloads, and should I look at something or not? If so, you can drill down and see a lot of details on what we're talking about and how the thresholds have been violated for that particular metric and what does it mean. So Brett can give some more samples on that. But one more slide for me, it is just about how we do the thresholds. I mean, we have some thresholds that are based on the hardware characteristics and that are fixed. So this example is about throughput. How many megabytes per second can this particular hardware configuration handle? Largely dependent upon the front end of the hardware and somewhat on the the processor and the cache in the back end. So these will vary based on your particular hardware and configuration. They can be changed, but actually in practice, that really only happens if the customer knows that their environment, they're pushing it very hard, they're near the edge of the capabilities, but they're maybe it's some batch workloads or something like that, and there's a tech refresh updated. So they don't get changed often. We find they're pretty accurate, and there's 3 different levels, and we're pretty smart about how we change the color scheme, the ratings regarding the violations into each level. There's another type of thresholds that are dynamic, as you'll see in this chart, where the thresholds, the 3 different areas of acceptable, warning, or really exception areas will change based on the flavor of the workload. This is a read response workloads, and so there's different types of reads, whether they're random or sequential and so on, and we'll take into account what is really acceptable from a hardware standpoint based on the flavor of the workloads. That'll hopefully give you just a little taste of kind of how we do the visualization of this process I've been talking about, this particular webinar is just designed to give you an overview of some of the capabilities. If you want a detailed demo of the product with some similar hardware to what you're running in your environment, that's obviously very easy for us to spin up as well. So at this point, I'm going to turn it over to Brett, and he'll go through some slides on modeling and then some case studies. Let's see. Are there any questions? I think not yet.
Okay, let's talk a little bit about modeling, and thanks, Brent, for that introduction, and then we'll go through some case studies. So we have a tool called IntelliMagic Direction. The reason why I want to talk about it, I want to talk about some of the concepts and why they're important to what Brent was talking about in terms of hardware domain knowledge. So what we can do with the tool practically is do predictive modeling for exact storage configurations, such as understanding hardware and workloads, predicting what happens when you add new systems to an environment or new workloads, understanding what kind of configurations would be most appropriate for the workload that you have, and looking at your automatic tiering, looking at how certain features such as compression would impact the performance of the environment. So essentially, modeling consists of the following equation. A configuration and workload is going to yield some kind of performance. Let's look at the abstraction of a configuration. You have host adapters or directors on the front end of a storage array. You have some number of processors in cache. And on the back end, you have device adapters or directors that interact with the cache in the midsection or on the back plane, and the disk storage on the backside of the storage system. In terms of the workload consists of reads and writes that are either random or sequential. And those random IOs are either hits or they are misses. So let's look at what we do with all of that kind of conceptually when we build a model of a storage system. We have some amount of input. That input goes into a queuing model, and the queuing model consists of adapter models and processor models and drive models. And there's a cost associated with doing a particular type of I/O, and we talked about the types of I/Os. So at each stage of the each queue, there is a cost, and the cost is either if it's at the processor level, each I/O has a certain amount of cost to the processor. And if you look at the workload and how many I/Os are coming through the system, you're going to drive the different queues to a certain utilization level. And when you look at how much time is spent for a particular I/O to be serviced, and you look at the queue time waiting to be serviced, you can aggregate those and get the response time. You can also assess how busy the individual queues, adapter, processor, drive, etc., will be in terms of utilized. How much percentage of time are they busy? When you add all the response times up, you get the overall response time. So this is the kind of thinking that goes into creating a model, and the kinds of things that you can do with it are you can do some merges and migrations. So this is an example where we have two older Vmax versions, some 20Ks, and we're looking at merging them on the two onto a one. So it's a 2-to-1 merge on a Vmax 40K, or maybe a VSP, or an 8870, or maybe it's the new ones. Maybe it's a Vmax 3, maybe it's the G1000, maybe it's the 8886. So there's different models that are in direction where we can do the merges to. In this example, what we're saying on the y-axis, we have service time, is that the average response time in the older models was around 2 to 2.6 milliseconds. And when we merge those, that workload, and we put it on the newer controllers, any of the new controllers can handle the workload without increasing the service time. So this is an important piece of information to have when you're going to look at moving to new hardware. So you have an end of lease and you're moving to new hardware. This is the kind of exercise you might find yourself engaged in. Now, usually what you do is you would create an RFP and you'd send it out to the vendors, and they would come back with their proposed configurations, but there wouldn't necessarily be a comparison in terms of performance. I'm certainly there would be some feature things that they would like to show and emphasize. Another thing that we can do is we can look at the predictability, or we can predict scalability, rather. And so we can look at different merge options, and the x-axis is showing the IOPS, the y-axis is showing the service time, and we can see as the workload increases, how does that affect my overall service time from the I/O storage system perspective. All right, so just as a backdrop, so that's the kind of information. We've been doing modeling for around 20 years. We developed several modeling tools for different vendors, and we use that kind of knowledge about what the storage systems can do to do some basic types of modeling in the tool Vision, which is what we're going to talk about and we're going to show our use cases. So it's maybe not all of these scenarios that we just showed, but it's this sort of mindset of understanding that workloads are different, that they behave differently on different controllers, and that different controllers have different thresholds. So when Brent talks about, these are the supported list of systems, we actually have to set, we have to know about the systems before we can set thresholds that make sense. So it is domain knowledge about each of these platforms and what they're capable of. And it's usually not something the vendor tells you. So I'm going to provide a few examples just to get the juices flowing, I guess. So this is a runaway query example, and in the front-end dashboard, this is for an SVC storage pool. And the storage pool happens to be a flash pool called SP Flash. And I see that there's some yellow there. Front-end read and front-end response time are both highlighted as yellow. Now, I also see front-end write response time in red. So Brent talked a little bit about it. The red is the exception. So the red is my worst case. Now, in this scenario, I'm not going to drill down on the writes. I'm only going to look at the read and the overall. And primarily, this is a read workload, so that's why I'm looking at it. And it's just the write is a different use case involving replication. So I drill down to the multi-charts that show me the workload and the response times over time, and I can see that the throughput peaks, and when it peaks, the read response time peaks, and also there's strong correlation with the overall response time. So I'm going to drill down on the response time to see who's doing the work. And what I see when I drill down is that there are 4 volumes that are doing about 100 megs per second each. Now, in reality, in the backdrop of this, we had identified some of these volumes previously, and they were doing around 300 megs a second. We weren't sure exactly who was responsible for them, so we decided to bump these down to 100 megs per second each and see if anybody noticed. So we did that. Nobody noticed, but what we did is we ended up digging in a little deeper, working with the system administrators. We found out that this was an AIX cluster, that these volumes on this, and it was volume 63 and system 30, these volumes that were having this very high throughput were hosting Oracle data files. So we ended up working with the DBAs, between the system administrator and the DBAs, pointing them to the workload and showing them what was happening. The DBAs were able to add some indexes, and so after they added the indexes, we went back and looked at it again. And just looking at the dashboard, after we added the indexes, the front-end response time goes back to green, and the read response time goes back to green. And when we look at the workload profile for those volumes, we no longer see the volumes that had 100 megs per second running constantly. So that workload is now essentially disappeared, and that's reflected in improved response time overall to that pool. So I'm going to pause. I'm just wondering if there are any questions before I go to the next one. Any questions?
Yeah,
Anybody want a Starbucks gift? Okay. Starbucks gift card. You got to ask a question.
There are some questions.
Okay.
What are some of the challenges you often see in maintaining performance and availability?
Well, I mean, it kind of depends on the environment. There's two main things that I usually see, and that's imbalances. So imbalances can happen really within any storage controller on the front end. And that's something where if things are imbalanced, you can start to run into performance issues and contention on the front end host adapters and ports. And that's really any system. The other thing that I often see is performance issues associated with replication. And replication is essentially trying to keep a consistent copy of data at a remote location. This requires sufficient bandwidth and sufficient cache and resources on the target system and also on the source system in the case where things have to queue up on the source system. So those are a couple of very common challenges that I see.
Okay, thanks.
Were there any other questions? Okay. Anyone else want to try to get a Starbucks gift card? Feel free to ask a question. All right. I'm going to go on to the next example, and this is for fabric convention.
I'm going to interrupt you. I have one more.
Okay.
He said, okay, so this is from Alan. With the case study you just showed, I don't see how this was something that could have been from the built-in array performance monitoring. How did the example go above and beyond the built-in capability?
So these dashboards that you look at, they're based on DSS thresholds. And they're based on DSS thresholds, even though it's storage pool data. For the response times in particular, they're based on what we think that controller can do in terms of response time based on the workload. So it is definitely based on what the capabilities are of the controller. So these thresholds show that there's a problem, and it's not just a simple threshold of like an SLO threshold, which is just saying we have a target of 5 milliseconds, and the ability, or we're getting 7 milliseconds, therefore issue an alert. It's looking at the workload, so it's looking at sequential, random nature of the workload, and it's looking at how efficient that storage system is at getting data through the system. And those are customized not only for the workload, but for the storage system. So that's kind of how that ties into the domain knowledge, if you will.
Okay, thank you.
Okay. All right, so how do we identify an issue where we have constraint on the fabric? This is an example where I have port utilization, an average port utilization for all switches by port WWN. And you can see on the y-axis I have 0 to 10%. So the average port utilization on these switches is not very high. However, I have a rating here of 0.75. Now, we didn't go into great detail in the rating, but the rating system is one of the unique features that enables us to identify problems. And what it's telling us is that we've spent at least 30% of the time above the exception, and that's why this is red. And so what I'm going to do here is I'm going to track this down. So I've got a rating of 0.75. If I look in the legend, I see BFJ_DB is at 0.75, and if I drill down to the switch ports by switch port type, I see that it's an F port that 0.75 is following, so I can just click on the line. That goes down and it shows me the actual port, which is slot 4, port 43. And if I drill down, I see the connected host WWPN for that slot 4, port 43. I can see that it's operating at 4 gigs per second. So this is a case where You can, if the throughput or the number of buffer credits is becoming an issue, in this case, the customer can decide to either make the HBA faster HBA by replacing it with a faster HBA or adding more ports to get more throughput. When you have a constrained port like that for many, many hours, you're often going to impact buffer credits, and there can be some buffer credit starvation. So, you know, you have to decide if it really is a problem or if you that you want to fix, and then if you want to fix it, how do you want to fix it? And there's a few different ways. So, any questions on the Fabric case study before I go to the auto tier?
Brett, there is a question on SVC Global Mirror.
Okay.
Oh, sorry, Jessica, but
That's okay.
It's about SVC Global Mirror replication.
Yes.
Environment experiences error code 1020s indicating issues with the WAN. What metric can be looked at to pinpoint where the issue might be?
You mean 1920s or 1820s?
1020s is what is put in there. But
oh, I've never heard of 1020s. I've heard of 1920s and 1820s. So
1920s, yeah, he typed
in
1920s.
Okay, now. All right. Yeah, that was like a quiz to see if I knew what I was talking about. So yeah, so if you're having 1920s, your application is getting behind. You're going to want to look at, there's several kinds of replications. So if it is the asynchronous global mirror replication or metro mirror, you have volume level statistics for PPRC tracks sent and received and response time. And so those are good to pay attention to. Also, if you look in the error log at the times when those conditions occurred, usually what you'll see is that the link got reset. And so the response time should go, the right response time should go way up during those times. If it's synchronous, you'll see that the front-end write response time is impacted. So you want to keep an eye on, for synchronous, of the front-end write response time. That's a critical metric. And then also the replication write response time. For global mirror with change volume, which is a bit trickier, you're not going to have those 1920s and 1820s, but you're going to want to keep an eye on, you're still going to want to keep an eye on the front-end write response time. Especially, you probably want to group those groups that are in a relationship so that you can keep track of the write response time. And then you're going to want to keep an eye on how long it takes to do the synchronization. So those are a few of the things. I mean, that's a big question, and I'd be happy to have a longer, more detailed discussion, but those are just a few of those things. But primarily, you're looking at how does my replication impact my front-end write response time, and then you can kind of go from there.
Okay, we had one more question.
Okay.
What metrics are port utilization rating based out of?
Those are based on the fiber channel. Basically, we're calculating the utilization from the capacity of the fiber channel link bidirectionally and the throughput that we're observing.
Okay, thank you.
All right, in this case study, I'm looking at some auto-tiering confusion. So in this case, we're looking at an HP3 PAR. You would take a similar approach regardless of, in terms of the analysis, regardless of the type of auto-tiering. You would just need to make sure you understood the auto-tiering, how it's set up, the logical components. And in this case, I've got three tiers. I've got a tier 0, which is SSD RAID 5. I've got a tier 1 that's 450 gig RAID 5, and I've got a tier 2 that's 900 gig RAID 6. And so I can combine one or more of those in the HP3 PAR adaptive optimization to form adaptive optimization policies. And in this case, I have two different policies. I have base DBAO and base ESX AO, and those consist of either for the DB, the SSD, and the 450s, and for the ESX, 450s and 900s. So in this chart, I see my policies and then any other non-policy activity. So I have the first one, which is my 450s and 900s. That's the red area. That's my ESX policy. I've got the 900 by itself, which is volumes that are not in a policy. And then I've got 450s and SSDs in the yellow, which represents the amount of data going for the DB policy. Now, so what? So let's take a look at how auditeering is functioning. On the left hand, I've got a section where I've got my 450 drives. In the middle, I've got SSD drives, and the right 900s. What this chart is telling you is the green dot represents the average, in this case, read IOs per second. The green rectangle is the 10th and 90th percentile, and the yellow rectangle is the minimum and maximum values. In this case, the y-axis shows the number of operations per second. So I have 150 on average, 150 IOPS per second on my 450 gig 10K RPM drives. For the SSD drives, I've got between 125 and 150 IOPS per second, and for the 900 gig drives, I've got around 50 IOPS per second. So what's wrong with this picture? Well, we've paid a lot of money for SSD drives, and we want them to be fully utilized. So that's one issue. The other issue is I've got 450 gig drives that are really going to be struggling at 150 IOPS per second because they're only 10K RPM drives. So I want to do some things where I rebalance the workload. So we made quite a few recommendations to this particular customer. One of the recommendations was to convert some of the SSDs, because only about half of the SSDs were getting used, convert that workload over to be a flash cache. So when we did that, we actually did see improvement. I actually just got the data yesterday. I don't have it in a slide, but we did see a significant shift in the workload from the 450s to the SSDs. So now that 450s are running at about 100 megs per, or 100 IOPS per second, and the SSDs are running quite a bit hotter. So that is, those are my examples. Are there any other questions before I turn it back to Brent?
No, there's no more questions.
Okay, great.
Time.
Okay, thank you, Brett. Let's talk about how to access this kind of technology as a service to give you an idea of how easy it really is to send us some data. And I'd like to make a few comments about how this problem is actually a very good problem to use in a software as a service mode. First of all, because it's very easy for us as the vendor of the software, of course, to keep it updated to the latest levels on the services platform. And as hardware changes fairly frequently, that's one of the things that we're really good at is including this knowledge about the specific hardware that you have on the floor into our interpretation of the data and what the data means. So that's an important aspect. It also gives very quick time to results. I mean, literally within an hour after sending us the data, I mean, you have to install a data collection process on your site. You can start to receive some visualizations. It's also okay for security. There's no personal information in the data. And it makes for easy dissemination of the visualizations. And finally, a very important point is the ability to access experts like Brett that are become familiar excuse me, with your environment. Typically, we'll bundle in professional consulting hours with the software as a service engagement so that we can do some proactive analysis, knowledge transfer, and be available as well if incidents come up that you want to augment your staff with somebody that focuses only on this area and is also seeing a lot of different things at different sites. The products that we talked about today are listed on the right-hand side. IntelliMagic Vision is the solution that does this kind of risk analysis constantly on your infrastructure. IntelliMagic Direction is the modeling solution. It supports all the vendors that we listed up at the top of the webinar. You may be familiar with a product called IntelliMagic if you purchased IBM hardware in the past. It's a product we've licensed to IBM to do some modeling in the sales cycle for 15 or 20 years now. There's also a version that we licensed to HP for some modeling of some of their storage arrays. But we've been doing this kind of thing for over 20 years and have, I think, actually a customer story here as well to talk about over. It's one of our European customers. It's a large environment with 76,000 employees in many different locations and a large storage infrastructure that we've added a lot of value to. So if you want some more details on this or some other user studies, there are some case studies out on our website, and at the appropriate point, we'll be glad to connect you for any references if that's important to you as well. But what we would like to emphasize is really how easy it is to see some more information. Typically, I mean, the next step, if you have some interest in exploring this further, would be to do a demo with one of our engineers using some data that's from a similar environment, or it may be possible to actually send you the data collector and send us some from your own environment so you can see it with your particular workloads. But the services engagement, using it as a service also makes it very easy for us to spin up a 1 or 2 or 3 month engagement, so you don't have to make a huge purchase decision in order to prove the concept. If you have more questions or any comments on that, my email is on there. I can connect you with the appropriate people that can help you. Let's see, at this point, is there some more questions, Jessica?
So we do have some questions. For the modeling of potential workloads, are you familiar with the load dynamics? Can you describe differentiators from them?
Yeah, I can talk to that. So that is actually a tool for capturing a workload and from your environment and then running the workload in a test environment. It does require hardware. This doesn't require hardware. This requires only that you capture the data, and then it actually does a mathematical modeling on within the tool of the different types of configurations. So you know, this is just a different approach. That's what I would call load or stress testing, and it's a good tool for that. And this is a different technique, which is modeling. So they're really two different approaches, and they're not necessarily overlapping. I mean, you know, you might, for certain situations, if you have a dev environment and a test environment where you can actually do those kinds of loads, then maybe that's something you would want to look at. If you don't have that environment, or if you don't have the time in the schedule to do that, but you still want to make sure that the vendor, you get a view from multiple vendors, you can use something like, well, Direction's really the only tool out there that's like that to do the modeling.
Okay, thank you. And the next question is, what is involved in sending data to your software as a service platform, and how long does it take?
So it really is just about installing a collector. It runs on a Windows guest VM, collects data from the infrastructure. It sends it via SFTP. For most environments, we can get it set up and running in like an hour or so. Some environments, there's other additional prerequisites, take a little bit longer, but that's the basic premise. So if we're interested in it, you would contact Brent, and then we would set up the environment for you and give you the software to download the collector and the prerequisites for it, and just walk you through it.
Okay. And another question is, what is the pricing for the software as a service option?
I'll let Brent take that.
Okay, sure. Yeah, it's priced based on the size of the environment and the number of hours of consulting that you want to wrap into it. So you can sign up actually just for a single storage array if you want to prove the concept, and just for a month or 2-month engagement. So we have customers that are small, similar to that, and we have some of the largest corporations in the United States as customers on our services platform as well. So we try to make it easy to prove the concept and go up. But I mean, to get an exact price quote, we would need to enter into a dialogue with more information about your particular environment and what kind of level of services you're requiring.
Okay, thank you. There's no other questions at this time. Oh, wait, one just came in. Can IntelliMagic software be purchased without the professional services?
Yes, sure. And actually, I should have mentioned, I mean, we have customers that purchase it and install it on their side as well, not using the services platform. So you can do it on-premise, you can do it on the services platform. When you do it on the services platform, you can contract with professional services hours as well. And that can be a temporary process as well for an assistance in knowledge transfer about how this process works and so on. Or if you've got, you know, the resources to handle it right away, we can just run the process for you, maintain the database, and, you know, ensure that the processing continually occurs as planned and desired. So.
Okay, thank you. Okay, so at this time, we'll go ahead and pull the drawing for the $25 Starbucks gift card. And it looks like Alan Ward is the winner. So Alan will be emailing you for the card shortly after the webinar. So congratulations, Alan. And thank you for everyone who attended. Again, we will send the recording out via email after the webinar. Thank you and have a great day.